The Hubble Space Telescope was a frontier for science and technology as we know it. It was the first major space telescope to be sent into space and is one of the most productive science instruments ever created. Before there were space telescopes, observatories had difficulty seeing any further or clearer because of the limiting factors of the Earth's atmosphere. Then, in 1946, an astrophysicist, Lyman Spitzer, proposed the idea of putting an observatory in space. Lyman Spitzer was a renowned astrophysicist that helped us push the boundaries of what we thought possible. He also contributed significantly to the study of the universe, nuclear fusion, and physics. The Hubble Space Telescope has made numerous groundbreaking discoveries. It has been in service for 33 years and has made 1.5 million observations that have inspired scientists, writers, filmmakers, and artists all around the world. The Hubble Space Telescope was not actually the first space telescope. The first operational space telescope was OAO-2, Orbiting Astronomical Observatory, second only to OAO-1 that failed 7 minutes after it was in orbit. OAO-2, nicknamed Stargazer, launched in 1968 and was NASA's first attempt at making the newly theorized space telescope and the largest space object launched into space at the time. Shortly after, Lyman Spitzer joined the OAO program and became the prime investigator of the development of the OAO-3. On the day of its launch, August 21, 1972, just before liftoff, he detected a potential engineering flaw on a drive motor that could cause the instrument to lock and become unusable. Spitzer immediately called the launch team and they came up with a plan to solve it. After the motor failed as expected, the mission was saved, thanks to Spitzer.
A new tool for the 80s will be the Space Telescope, weighing 5 tons and measuring 43 feet long by 14 feet in diameter. The Space Telescope will give astronomers unprecedented views of space, unobstructed by the veil of the Earth's atmosphere.
In 1979, with the help of the European Space Agency, work began on a much more powerful telescope at a Lockheed Martin facility in Sunnyvale, California. The telescope was going to be massive, 43 feet long, 14 feet wide, and would weigh in around 27,000 pounds at its completion. NASA hired Perkin-Elmer to create the large 7.9-foot mirror needed for the telescope. In 1983, the project was named in honor of astronomer Edwin Hubble, who proved there were other galaxies in our universe. Development of the Hubble Space Telescope continued for nearly a decade until its launch in 1990. The Hubble Space Telescope uses a mirror-based optical system, which is used to collect and focus light so we can see things very far away. The optical system, or Optical Telescope Assembly, OTA, gives Hubble a unique view of the universe by gathering infrared, visible, and ultraviolet light. The primary mirror is 7.9 feet in diameter, and its secondary mirror is just 12 inches, which allows the telescope to see 40,000 times the amount of light seen by the human eye. Meaning, Hubble could see the landing lights of an airplane over San Francisco from Washington, D.C. Hubble's first image, which is called First Light, was taken in May of 1990, and it was used to compare it to a picture taken by the Las Campanas Observatory in Chile. The picture taken by the Hubble Space Telescope was much clearer than the ground observatory. The images of the stars in the ground-based picture are fuzzy, and in some cases overlap, because of the smearing effect of the Earth's atmosphere.
The subcommittee will come to order. I'd like to apologize to our witnesses and our guests for the delay in starting this morning, as this afternoon now. As I'm sure has been explained to you, we have been in a lengthier than we expected classified session on aspects of this issue which cannot, for good and valid reasons, be discussed fully in an open session.
The Hubble Space Telescope did not have a smooth start though. Soon after its launch in 1990, the unexpected happened. It suffered from a spherical aberration. Not all the portions of the mirror focused to the same point. The mirror's shape was off by less than 1/50th of the thickness of a human hair. But this tiny flaw proved devastating to the quality of Hubble's images and to the efficiency of all of its instruments. Perkin-Elmer had ground the glass too thin. This caused outrage across the US. Investors like Senator Barbara Mikulski were very disappointed and started to make fun of the project. This was a low point for NASA, and as more information got leaked about the problem, they became increasingly embarrassed, especially because of the recent Challenger disaster. This was not good for NASA, as they were hoping to get funding for the ISS at the time. Over the next couple years, NASA worked on a solution to the problem. Luckily, the mistake was made with extreme precision. By calculating the differential between the actual and desired mirror curvatures, a set of corrective optics could be designed. Hubble was getting glasses. Hubble was not completely useless though. During the time the Corrective Optics Space Telescope Axial Replacement, or COSTAR, was being built, engineers were able to create software algorithms that could help with the blur of the images, allowing for 25% of all research papers submitted to the American Astronomical Society to use this data. Hubble also made many discoveries during the time leading up to the COSTAR's installment. In 1993, COSTAR was installed and repaired Hubble's vision of the cosmos.
It's really been, I think, much more successful than anyone would really have anticipated. I mean, when Hubble was designed, there were a number of projects that were thought key projects for the observatory, and it would go and do those, and we'd learn more about the universe, and indeed it's done those. But you know, along the way, it's been much more effective in doing a very broad range of astronomy than was imagined. And you know, in fact, I think it's true to say that it's revolutionized astronomy.
In 1995, Hubble captured an image of the Eagle Nebula, first discovered in 1745 by Swiss astronomer Jean-Philippe Lois de Chasseau. The portion of the nebula that Hubble captured was especially fascinating. The image, named the Pillars of Creation, is a massive gas cloud about 4 to 5 light years across that formed into the shape of 3 massive pillars. The image is now Hubble's most famous photograph and is one of the most well-known images in all of astronomy. After the repair of the Hubble Space Telescope, it has made over 1.5 million observations that have greatly impacted our knowledge of the universe. With the use of Hubble data, astronomers have published more than 19,000 scientific papers, and those papers have been cited in other papers over 1.1 million times. This has enabled the Hubble Space Telescope to be one of the most productive scientific instruments ever built. Hubble has also inspired the creation of the James Webb Telescope, which was just launched at the end of 2021. With this new technology, Webb is able to see things too distant or faint for Hubble. The James Webb Telescope uses much longer wavelengths of infrared light that allow it to see through gas clouds much more easily. Today, Hubble is still in use after its final servicing mission in 2009, and continues to make discoveries that help us push through our final frontier, space.